Welcome to Saxon Math, Course 3, Lesson 115, Starred Problems. Now, the first starred problem is problem number 3. Problem number 3 says that Samantha has 21 nickels and dimes. Now, we're taking that to mean that between her nickels and dimes, she has 21 of them total, not that she has 21 nickels and 21 dimes. I say that because it says that between her 21 nickels and dimes, she has $1.60. And if she had 21 dimes, she'd have more than $1.60. Now, this can be represented by these two equations. U plus D equals 21, and 5 times U plus 10 times D equals 21, where U is our nickels and D is our dimes. We know that U is the nickels because it's being multiplied by 5. This is the value of how many coins do we have total. This is the number of coin times how much it's worth, plus the number of the other coin times how much it's worth, added together, equaling the number of cents we have. Now, as we're going through this, if we create some charts, we're going to say that if we were to plug in 0 for D, well, if we have nothing plus D equals 21, then D is 21. If we have 1 plus D is 21, well, it'll be 1 less than 21, or 20. 2 less would be 19. 3 less would be 18. And then I skipped a bit here so we can make sure that we're fitting onto the graph that I made. If we had 10 plus D, 10 less than 21 is 11, and 11 less than 21 is 10. So we've got 21, 20, 19, 18, 11, and 10. On this side, 5U plus 10D equals 160. If we plug in 0 for U, we'll get 10D equals 160. 160 divided by 10 is 16. If we plug in 5 times 2, we're going to have to subtract 10 from both sides, because 5 times 2 is 10, which will give us 10D equals 150. Dividing that by 10 will give you D equals 15. Now, if we plug in 4 for U, that will give us 20. So if we subtract 20, 10D will equal 140. And when we divide, D will equal 14. So we've got 16, 15, 14. So we've got two equations here. This one will probably be the easier one to draw first. Now, 0, 16, if we go up 4, 8, 12, 16 is right here. 2, 15, that's 1, 15. 2, 15 will be right here. And 4, 14. So ignore that first red dot. Now, if we know this is 16, 0, 21 would be up 5 further. So we can imagine it might be somewhere here. 120 would be here. I'm going to switch to a different color. We're kind of going through this chart, but the point where they cross should be further down. So 3, 18. And then we've got 10, 11. So if we go over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and up 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 11, 10, which will be 1 down. Now, I put these here because I'm not going to draw the line up at top, but I am going to connect with my straight edge to make sure it's lining up neatly. I'm going to avoid drawing a line through the chart that I made earlier. And then we'll connect the other 3 dots we made. And we can see that there's a clear point of intersection. And we're intersecting at this point 10, 11. which was our nickels and our dimes. So one way to check your work is to plug 10, 11 back in. So if we say 10 plus 11 equals 21, that one works. That one's really obvious. We can just say 10 plus 11, it is 21. What about 5 times 10 plus 10 times 11? Does that equal 160? Well, 5 times 10 is 50. 10 times 11 is 110. And that does equal 160. So we've checked our work. Now, it's important when you solve a system of equations, plug it back in. Make sure your answer works in the equation. If you don't do that, you might spend all this time graphing, accidentally make a small mistake, and end up with a wrong answer. Because it's okay to make mistakes. It's not okay to not check for them. Now, question 4 says to find the area of triangle FBD by subtracting the area of 3 smaller areas in rectangle ACE. So we've got 3 triangular areas around this triangle here. Now, the rectangle is a 3 by 4 rectangle, which 3 times 4 is 12. Finding the area of these 3 triangles, we're going to take their length, and then we're going to multiply them by their base times their height, and we're going to divide that by 2 or multiply by a half. So if we have 3 times 4, that's 12. Half of 2 is 1, times 3 is 3. Half of 1 times 3 is 1.5. And half of 4 times 2 is 2. If we take 12 minus 3, that's 9. So we're going to have 9 minus 1.5 minus 2. And then 9 minus 1.5 is 7.5. And from 7.5, we're going to subtract 2. And 7.5 minus 2 is 5.5. And now we found our area. Alternatively, we could have used the Pythagorean theorem to find this length. Said that it was going from here to here in a sweep, but we would also have had to find its height, which would have been a little bit tricky. So, if we have a compound shape that we can find the 3 triangles around it, might be a little bit easier. Now, question 5 says list the sides of triangle FBD from least to greatest, and then the angles also from least to greatest. So FBD was this triangle we had down here. Now, when we look at triangle FBD, we have this side here, which we can remember that we're going to be able to use the Pythagorean theorem for this. It's going to be the other 2 sides squared and added. So 4 times 4 is 16. 1 times 1 is 1. 16 plus 1 is 17. So this is going to be the square root of 17. This side here, 2 times 2 is 4. 3 times 3 is 9. The square root of those 2 added, 4 plus 9 is 13. And then this last one, 3 times 3 is 9, and 1 times 1 is 10. So this is going to be the square root of 10. 1 times 1 is 1, plus 9 is 10. I'm sorry, misspoke there a little bit. So now we can see, of these, even though we don't know what the square root is, we can say which one is the smallest, which one is the biggest. So we can put them in order. We can say that if we're going from least to greatest, the smallest one is root 10, which was side DB. The next smallest was the 13, which was side FB. And then the final side, the largest, was FD. Now, remember, we can look back at the angles which create them, or we can use that trick where the letter that's not in the name of the side is the angle which formed the side. So here we're missing angle F. Here we're missing angle D. And here, angle B. Meaning that angle B is the largest, angle F is the smallest. And we can see that here. I'll show you in the graph, where angle F is the one which makes angle DB, or line DB. Angle D is the one which creates side FB, and angle B is the one which creates the largest side. So we can see here that it is going to go in order F, then D, then B. Which is what we had. Now, question 13 asks us to find the perimeter and the area of a rectangle with vertices 0, 0, -2, -2, -3, -1, and -1, 1. Now, I've drawn that here, 0, 0, -1, 1, -3, -1, and -2, -2. Now, in order to find the perimeter and the area, we need to find the length and the width. Now, if you notice here, each of these is formed by a isosceles right triangle, which means that the leg length here is √2 is the hypotenuse length divided by √2. So if we have a leg of 1, then the hypotenuse is 1√2. So this is 1√2. If we have a leg of 2, then the hypotenuse would be 2√2. This has a leg of 2, so we have 2√2. So our length might be 2√2, and our width could be just √2, or 1√2. Now, when we're finding the perimeter, we're going to add 2√2 and 1√2. Now, if we have 1√2 plus 2√2, that's going to be 3√2. And if we multiply 3 times 2, we get 6√2. Now, to find the area, we just have to multiply the length and the width. So we're going to have 2√2 times 1√2, which would give us 2√2 times 2, which is 2√4. The square root of 4 is 2, so it would be 2 from the coefficient times 2 from the square root, giving us 4. Question 14 is an interesting one. It says that if the rectangle in problem 13 is rotated at 90 degrees clockwise, what are its new vertices? So I've gone ahead and I've written out 0, 0, -2, -2, -3, -1, and -1, 1. Now, I'm going to label these A, B, C, D. Now, I'm going to say that this is A, the 0, 0. This is B. This is C. And this is D. Now, I've done that because I'm going to rotate your view 90 degrees clockwise. So we're moving in the direction that a clock would go, and we're going to make a full 90-degree turn. Okay, so now all of my writing is been rotated, but the shape has been rotated too. And we can see that A, right here, is still at 0, 0 for A. Well, what about B? Well, now B is still -2 over, But it's up 2 instead of down 2, isn't it? We have to go 2 to the left and 2 up. C is 1 to the left, so C would be negative 1, and then it's 3 up. And D is now 1 to the right, and 1 up. So as we're going through, I'm going to be writing sideways, but I'll rotate the camera back before I flip the page. We're going to have A still be 0, 0. B is negative 2, 2. C is 1, negative 1, positive 3. And D is 1, 1. And now as we rotate back, we have our solutions. Now, as we're looking at this, it's a little bit tricky because it's kind of hard to see a pattern of what's happened here. But what we can remember if we recall our rules is if we have x, y before the translation, then after the translation, we'll have our y become our x, and our x become our y, and the new value in the y will be multiplied by negative 1. And you can see that happen. So this negative 1 moved to the y, but then became its opposite. This negative 3 moved to the y position and became positive. The negative 1 moved to the x position. So if we're rotating 90 degrees clockwise, the x and y are going to switch places, and the number that ends up in your y place will switch signs. Question 18 is our next star problem. It asks us to graph y equals negative 1/9 x squared. Now, if I think about ninths, I want to think about multiples of 9. Now, multiples of 9, you got 9, 18, 27, 36. Now, of these, which of these are perfect squares? Well, 9 and 36 are perfect squares. 9 comes from 3, and 36 comes from 6. I'm going to use 3 and 6 as my inputs, because I know whatever I put into this equation, I'm going to square it, giving me these, and then that will be easily divided by 9. When you're thinking about your inputs, try to come up with numbers which will fit in this equation well. So negative 6 squared is going to be positive 36. 1/9 of 36, well, that's going to be negative 4. If we have negative 3 squared, that's 9. Negative 1/9 of 9 is negative 1. Now, if we have y equals negative 1/9 of 0, 0 squared is 0. 0 times anything is 0. So we're going to have negative 4, negative 1, 0. And remember, if I change these to positive, they will still have the same value here. Now, if you get to the point where you see an equation where it says y equals x squared plus x plus some number like 3. Now, notice this has a non-squared x. In this type of equation, you cannot just mimic immediately across from here. You will have to find the center of the parabola and then reflect. But if we don't have this term in the middle, if this is missing, then this will reflect across the y-axis. So we can know that it's going to be negative 1 and negative 4. Now, if we have 0, 0 right here, negative 3, negative 1, and 3, negative 1, 6, negative 4, and negative 6, negative 4. Those are going to be the points on our parabola, and then all we have to do is just create a nice, gentle curve. And it's a little bit easier to do this with pencil, because you can sort of erase. And as this gets further away from the y-axis, it's getting steeper, and you want to try and imply that. It never becomes a straight line, but it does get steeper and steeper as it goes, because larger numbers are going to have larger values when you've squared them. Now, our penultimate starred problem, question 19, is to write 1.16 repeating as a mixed number. Well, it's got a repeating decimal, so we're going to need to use our trick for getting rid of the repeating decimal. Now, if we multiply f equals 1.16 by 10, we'll get 10f equals 11.6, 6 repeating, because we've moved everything 1 to the left, and we've left the 6 repeating over there. Now, if we subtract the original equation, 10 minus 1 is 9, 11 minus 1 is 10, 6 minus 1 is 5, and the 6's will cancel out. We then need to divide by 9, which will give us 10.5 over 9. Now, we shouldn't have a decimal in a fraction, so I'm going to multiply everything by 2. Now, 10.5 times 2 is 21. 9 times 2 is 18. Both of these are divisible by 3. Now, that will give us 7 over 6 if we divide by 3, and divide by 3. And 7 over 6 as a mixed number is 1 and 1/6. Now, for our last starred problem, question 20, we're going to have x squared minus 9 equals negative 25. Now, the first thing you should do is you should add 9 to both sides. Now, if you add 9 to the left-hand side, you just get negative x squared. If you add 9 to 25, remember opposite signs, you find the difference. 25 minus 9 is 16, but 25 is the larger number, so it's going to be negative 16. Now, we cannot take the square root of a negative number. It doesn't exist. So we first need to multiply both sides by negative 1, giving us x squared equals 16. Then we can take the square root, and we'll get plus or minus the square root of 16, which is 4. And that's our final problem for the day. I hope you enjoyed these questions. I hope they were helpful, and they answered any questions you might have had. Stay safe, stay inside, and wash your hands.